Okay, today we're going to talk about our third tab of the foldable that's on families of functions, which is Unit 13. We're going to talk about quadratic functions. This is something we've actually done quite a bit, so a lot of this will be review as we go over it. So go ahead and take a minute. We're going to have two tabs. This is our first one. Go ahead and take a minute to copy all this down and see if you can answer it on your calculator. Okay, we can do most of this on your calculator, so go ahead and graph the function on your calculator and see if you can remember how to find all of these things. For zeros, go ahead and round to 3 decimal places for your zeros. Okay, round to 3 decimal places for your zeros. Okay, so we'll go to our graphing calculator. I'm going to go to y equals. I'm going to go and type in the equation, so -2, x minus 3 squared, and plus 5. And so I'll go ahead and graph it. Okay, so there we have it. So if you remember, your vertex ends up being the highest or lowest point on the graph, so that would be my vertex right here. Okay, so I'm going to go ahead and write it. And your zeros, it doesn't matter what graph you're talking about, it's where it crosses the x-axis. So I have 2 of them, if you remember what those. So those are my zeros, okay, in blue. So the first thing I'm going to do is I'm going to go ahead and try to find my vertex. So right now, looking at it, I know my vertex is a maximum. So I'll hit second trace, okay, and we'll go ahead and go to maximum. And remember, it'll ask you to pick a number, an x value on the left of your vertex and one on the right. Usually you can use -10 as one on the left, hit enter, and +10 as one on the right, hit enter. Hit enter one more time and you will see it will highlight your vertex. So our vertex here is 3, 5. Okay, it's 3, 5 if you end up rounding that, so 3, 5. So let me go back. Okay, we're going to go ahead and type in 3, 5, or write in 3, 5. And if you remember in a table, when you're doing a table, your vertex ends up being the middle part of your table in MathXL, so 3, 5. You should also know that it was 3, 5 without doing any work at the beginning. Here's why. Our original equation right here is in vertex form. So remember, the opposite of the number inside the parentheses is your x-coordinate of your vertex, and the number at the end ends up being your y-coordinate. So we kind of would have known the vertex already if we had looked at that and figured that part out. But either way, it's good to graph and check. Let's go ahead and find our zeros now. Okay, we'll find our zeros. Okay, so I have 2 of them. So again, I'm going to hit second trace and 0. And you can try to use -10 to 10 again, just like you did before, and it'll at least highlight one of the zeros. So if I erase where I have this, notice how it's highlighting the one on the right. So the one on the right is 4.581. So let's write that down. So 4.581. Okay, and I still need to find this one on the left right here. So again, let me go into second trace 0. Now, in order to find this one, I need a number on the left, so I can use -10 again. But you do need one on the right of that doesn't go too far. So you need one that's in this area somewhere on the right of the 0. So I could use, it looks like 1, 2, or 3 to do it. I'll just use 2 to be safe. So 2 is an x value on the right of that 0. And again, if I do it right, it should highlight it. Okay, which if you look, it is. Okay, so 1.419. Okay, 1.419. So let me go ahead and write that one in. So 1.419. Okay, let's figure out the table then. Okay, so I have my graph. If you want, you can go into your table. So second and table. And we already know our vertex, okay, was 3, 5. Okay, I have that right there. And notice on your table, you go 2 points below the vertex and 2 points above it. So there's your table right there. And notice the pattern. Notice that the points above and below the vertex have the same y-coordinate. And if you go 2 points above and below, they also have the same y-coordinate. And if you went 3, if you kept going, just putting a bunch of dots there, they have the same y-coordinate. They follow that pattern because the y values repeat since the graph makes a u. So I'm going to go ahead and fill these in my table. So I need to remember -3 and 3. Okay, so I'm going to go back in. So we know this first y-coordinate was -3 and 3, and we knew they repeated. And I'll go ahead and fill the rest of my numbers in, again, that were on the table. All right, all the graphs we've been talking about go on forever left and right, which means your domain is every number, okay? Because the x values can be any number left or right, so all reals. Your range, however, is a little bit different on this. Okay, so let's go back and look at our graph. Okay, let me erase some of this. And what you'll notice if you look at your vertex had a y value of 5. Okay, your vertex had a y value of 5. So how are all your y values compared to 5? Well, if you look at the graph, all of them are below it. So your range, which are the y values that show up on the graph, should be y is less than or equal to 5. Okay, all your y values are less than or equal to 5. So I'll go ahead and write that down. So all your y values are less than or equal to 5. And then this last question we've had is a common question. It wants to know the rate of change from f of 2 to f of 4. So that's where x is 2 to where x is 4. If you remember, rate of change is the same as slope. It means rise over run. So if you look and you go from a y value of 3 to a y value of 3, your rise ends up being 0. You didn't go up or down at all. And if you look at your run, which is the x values, you're going from 2 to 4. So you'd be moving 2 spots. So you would have 0 over 2 or just 0 for that. Okay, for our second slide, or final slide, what we're going to do is we're going to analyze either a graph or a table, and we're going to try to write a quadratic function that models the graph or table. So you need two things to model an equation, to write an equation in vertex form. You need a vertex, and you need another point on the graph, which I have here. So if you remember, if you go up here, we used to write it in this form. We used to write it real easily, okay, by using your vertex. So if you remember your vertex, this coordinate right here, the opposite goes inside the parentheses. So the opposite of 2 is -2. And the y coordinate goes on the outside. And that's what we used to do. What's new to us is we still have this a in the problem. Okay, I still have that a in the problem that I need to solve for. So what you're going to do is you're going to use another point on the graph to fill in for f of x and x so you can solve for a. So we know this is really our x coordinate in our table. We know this is really our y coordinate, or f of x coordinate in our table. So I'm simply going to fill those in up here and solve for a. Okay, so f of x ends up being -7. X ends up being 3. Okay, so that's what I end up getting. So if you look inside the parentheses, okay, 3 minus 2 inside the parentheses is 1. 1 squared is still 1. So really you just have 1 times a. Okay, whatever number's in the parentheses that you get when you square it, you put that number in front of a, and then you have -4. So to solve for a, I would add 4 to both sides. Okay, so you get -3 equals 1a. And then I would simply divide by the number next to a, which is this case 1. So you would figure out a equals -3. So at the end, my final equation would be f of x equals, I'm going to fill in my a, and then I'm going to fill in my vertex for the other part. Okay, just like I did earlier. And that would be the equation, okay, that would model this graph. And again, sometimes they'll give you a graph, sometimes they'll give you a table. But as long as you know the vertex, and you know another point on the graph, you can write an equation.